Hey guys, it's me Pavitra, and I got the chance to interview Chloe Mathon, the founder and CEO of Hydrogen Aerospace, an aerospace company founded recently in France. They are currently working on their first orbital rocket, which they expect to fly sometime in 2027, carrying a 2,900 kilogram payload to polar orbit. Now, in case you haven't already noticed, this is a really long video. So grab your popcorn and let's understand a bit more about Hydrogen Aerospace. So, who is Chloe?
Okay, so I'm a student, so I'm 19 years old, so it's a little bit young to be an entrepreneur. I'm 19 years old, so I'm passionate about space since my childhood. I do coding since I'm 12, so I started young working on computers. So in my field, in that I study, I'm in network, so IT, of course, and computer science in general. And so I do coding since I'm 12, and I wanted to do some space stuff with my knowledge, and so I tried a few things, and now it's hydrogen.
Yep, 19 is definitely an ambitious age to be starting a company like Hydrogen Aerospace. But hold up, what's Hydrogen Aerospace in the first place?
Okay, so I said previously, so I do coding since I'm 12. And so I started having fun with electronics. And so I wanted to build a CubeSat because everybody do a CubeSat. Uh, and and so while I was working on this CubeSat, I just had the idea, oh, okay, what it will cost me to launch this CubeSat to space. And when I saw the price, even with Rocket Labs, etc., a lot of small set companies, it was really high. I think we were around 1 million for just the CubeSat that I can have in my hand. And and so I came up with the idea that we can do things better. And of course, uh, because when you do a satellite company or a startup with CubeSat, you just want to have your CubeSat to space. You don't care about having options or having a dedicated launch. So I came up with hydrogen. And it's also because in Europe and in France, we don't really have a lot of private aerospace companies. So I think we can help all the well-established companies, but also the student project, government agency, uh, get a satellite to orbit for a very low price.
The price of launching a small CubeSat, even today on rockets like the Electron from Rocket Lab, is very, very high. And while you can hitch a ride to space on big rockets like Falcon 9 alongside bigger satellites, it rarely gives you the specific orbit you wanted your CubeSat to be in. The advantage Hydrogen Aerospace has over other small sat launching companies like Rocket Lab, Virgin Orbit, etc., is that they have a medium sized rocket that's going to launch a small satellite. But hold up, didn't we just say that launching a small sat on a bigger rocket means you usually don't get the precise orbit you're looking for? Normally, this is the case, but Alhena actually features a kick stage, which we will talk about more later in the video. This acts kind of like a third stage, which will take any rideshare payload to the specific orbit that they require. Another way in which Alhena will bring down the cost of launching a CubeSat to space is by reusing the first stage. Again, we'll be talking more about this later in the video. So when can we expect to see some hardware?
So the near future is we will start working by September on our first rocket engine. Then in mid future, we will start. So we will start the development of our first rocket engine. Then we will test it. Then we will start working on our flight engine and structural at the same time. And the rocket will basically go like that.
Only a month or two back, Chloe was the only person working at Hydrogen Aerospace, and even as of the making of this video, it has only 7 people working there, soon to be 15. So you might ask, how much do they expect to grow in the future, employee wise?
I think we will not grow that much in terms of employee. Of course, we will grow a lot more than 15, but we want to. My goal is to have a small team because the bigger you are in terms of employees, the less productive and efficient you are.
Yeah,
But
the decision-making efficiency goes down.
yeah,
right?
so that's why I want to keep the team small at the beginning. But even 15, I think it's a big number right now. But we have really great talents in our team, and that's why team will be maybe bigger than I expected. But you know, it's the funny part of doing a company and even more a space company. It's because you learn every day. And so, you know, right now we have a legal team, and I didn't expected that I will have a legal team in less than 6 months, but we have to have it because we work on weapon basically. So we have to deal with these laws.
That is certainly very cool. Now let's just dive right into the very exciting technical details about Alhena.
Alhena is a medium launcher, so it can launch 2,900 kilograms to polar orbit. This rocket is, if I'm not wrong, 2.5 meters wide. Sorry. The length, I will not specify the length because I don't know it, and because it will change, so I will not say it. But it's bigger than Vega. Because in fact our capacity right now, our payload capacity will be more bigger than Vega right now, so the bigger launcher. But so we don't know what matter. We have an idea, but I will not reveal it. But we will use some materials that are very common. So we will not use carbon fiber, for example, because carbon fiber costs a lot and take a lot of processing. But I talk about the rocket, but right now all our work, is focused on our first rocket engine. But the rocket will feature four engine at the first stage, and then a vacuum optimized engine for the second stage. And we will have a kick stage in the fairing. And basically, this kick stage will allow us for rideshare mission, or even dedicated, but more for rideshare, to allow our customers to have a dedicated orbit. And I think it's one of the quality of Alhena. It's because even if you will not pay a big, it's a low-cost launcher, you will have a great capabilities with this launcher. And having a dedicated orbit, it's really great for customers. So that's our goal with this rocket.
Now, since we already know that the first engine that they will be developing is their kickstage engine, the first question that pops into mind is, what are the specifications of this engine?
So right now for this engine, so we will start designing this engine in September, but we are in technical study. Basically, we know that it will be a pressure-fed engine. This engine will be will not be big. Basically, I will be able to fit it in my hand. It will be 100% 3D printed, and it will be a 5 kilonewton engine, and it will run on Metalox.
Yeah.
I will explicit a little bit because maybe people will say, wait, you want to send 2,900 kilograms to polar orbit with a 5 kilonewton engine? Right now, we are developing and designing our first rocket engine. So it's, of course, the kick stage engine, but right now we are not designing it to be the kick stage engine. We are designing it to be an engine that works and don't explode, basically. So at first, we will start designing this engine to run on to run at sea level. And we will basically improve it. So it's a test bed. Basically, we want to learn from this engine. We want to test new thing, innovate, even maybe why not just brew up some engine just to see push it to the limit. But we want to learn from this engine, and with all the experience that we will learn from this one, we will be able to do our first stage engine and of course our second stage engine. So it's more a testbed or a bootstrap engine than active stage engine right now. But of course, we don't want to lose all the research and development on it. So we will reuse it for our kick stage, and we will have some modification, of course, to have it running at sea level. In vacuum.
So the kickstage engine is a fully 3D printed Metalox pressure-fed engine that has a planned thrust of 5 kilonewtons. That was a mouthful and very exciting. What Hydrogen plans to do here is get some rocket engine development experience by first trying to make the kickstage engine. Then using what they learned while making this kickstage engine, they will develop the main first and second stage engine. So I did mention that Alhena features a reusable first stage and a reusable fairing. So let's learn a little bit more about how Hydrogen Aerospace plans to reuse this hardware.
So the first stage, some people are, I said, what you want to do two reusability methods, but right now we want to reuse this rocket with parachute, but it has never been done at this scale. So we want to develop the two methods apart. And if parachute fail, okay, we will go to propulsive landing. But I think parachute is more easier solution because you don't have to, you just need a boat basically, or an helicopter. And it's more easier than having a ground pad or drone ship, because our goal with hydrogen is not just focus France, but focus almost everywhere customers need us. So we have to think how we can reuse it easily. Having a ground pad can be an obstacle for the reusability. So we are focusing on parachute, and if it fails, we will do propulsive landing. But I think it can work with parachute. And for the pairing, we will do it with parachutes. So we will recover them from water.
Another question that comes to mind is, what material will they be using to produce their rocket?
We don't know yet, but it will, I think, be something, it will be aluminum or stainless steel. Of course, it will have a lot of dry mass, but the rocket in terms of structure will be allowed to handle more heat, basically. And the primary why I want to choose aluminum or stainless steel, it's because it's very easy to process. You just have to cut plates basically, and it's very common. So the more common our resource or material is, the more cheaper it is. And so we have a great capabilities to bring the cost down, but we also, even with reusability, we want to bring the cost down for a brand new first stage that will come out from the factory.
So when can we expect to have some more information about the engine? Like, when are you starting development of the first stage engine?
So we will start working on the first stage rocket engine development when we will be confident about our small scale engine. So basically when a lot of testing will be done on it, and then we will be able to start from a clean sheet of paper with all the experience that we learned from this small scale engine and this first stage engine. But I think it
Okay.
will be so. You know, we all know the Elon time for SpaceX. I think you will know the Chloe time. So I'm very optimistic, more than my angina. I think this rocket engine could be developed in the first stage rocket engine could be developed in 2 or 4 years. I don't know.
Do you plan to make bigger rockets in the future?
Yeah, I think we will do a bigger rocket, but I don't know anything about it. But I think, yeah, we will do a bigger rocket if the market need it, and if we see that our customers need a bigger rocket, of course. Maybe Alhena will have upgrade. Never say never, but yeah, we will have a lot of experience from Alhena, of course. So doing a bigger rocket is, I think, the next step, of course.
Okay, so that's pretty much all that we know about the rocket and the engines. The other details haven't even been worked out yet. So now let's see what Chloe thinks are some of the biggest challenges in manufacturing and launching a rocket.
I think so. The production will be, I think, really easy because we will use aluminum or stainless steel. I think the biggest issue we have with Alhena right now is launch site because we are in Europe, so we need to find. So I'm not against having us to build our own launch range, like Rocket Lab with Maya Peninsula. But I think we will. It will be a big issue because we have great launch sites in Europe, like Sutherland, Andoya in Norway, I think, and even one in Spain. But you know, it's not in France. Of course, we have Kourou, but Kourou is great because it has a lot of infrastructures, tracking dishes, etc. But it's really far, and so you have to move your rocket. And I think it will be the biggest issue with Alhena. It's to know how we will process, how we will move this rocket from factory to its launch site.
In the future, are you thinking of selling other services apart from launches, like the way Rocket Lab has its Photon satellite bus?
Yeah, I think right now the Hydrogen just want to help people having their satellite to orbit with dedicated orbit, etc., even if they are on rideshare. I think the logical next step is to help them build the satellite. I think we will do maybe spacecraft systems subsidiary in the future. Why not? But I think it's the logical step. You know, I started Hydrogen to help because I have a lot of friends that are studying aerospace in France, and I was somehow sad because they build satellites at their school, but they can't launch it because it's just too expensive. But I
Yeah,
think
it's too expensive.
we have a lot of people right now, even with all the public attention from because of SpaceX, Elon Musk, Starship, because a lot of people are interested in space, and so they bring new ideas, but they are not developers, they are not engineers, and so they don't know how to build a satellite. But they have great ideas, and I think we can help them getting their ideas to orbit. So I think yeah, we will maybe do it. The goal is to help just people that have ideas, but they are not really engineers, because our team will be able to help them. And we will have great engineers, qualified engineers that will understand what they want and then help them get their satellite to orbit. And I think it's even more great for them because you know the issue with CubeSats right now. If you have to build a CubeSat, so it's hard. You have to know how to build a CubeSat, and then you have to launch it. But to launch it, you need to raise money, and to raise money, you need investors or VC. But no one will know if your CubeSat will work. If the launch is a success, will maybe have a dead satellite in orbit. And I think it will be more, the investors will be more interested in this solution because they know that it will work, the satellite will work, and are in good hands with a very qualified team, and the company or the customer with his ID will just have to pay all services and not a big team right now. It's somehow part of how we do satellite right now with Thales Alenia Space, Lockheed Martin, Boeing doing satellites.
Once Alhena starts flying, what do you expect the launch cadence to be? How frequently will Alhena be launching?
So at first we will. So when you start a work, when Alhena will start flying, of course its launch cadence will be very low. It's all the rockets are concerned with that because you need to understand your system, you need to know how it works in space, and you need to get the mood of doing rockets in a loop and mass producing it. But we will target, I think, at the beginning, so maybe 1 year after its first flight, each rocket a month, one rocket a month, sorry. And then I think we will start, the long-term goal is one rocket a week. Yeah, our goal with Alhena, and I think it's one of the flow of all aerospace companies. It's because they are established in just one country, or even Rocket Lab is in two, but they stay at home basically. Our goal is to have subsidiary. Right now we have in England the Brexit, so we have England people. England has a very big problem because they don't have a rocket right now because they are not in the European Union, and so they need rockets. So right now we can see that Virgin Orbit is going to launch in England, and so I think it's one of the long-term goal of Hydrogen. It's having subsidiaries in each country where they need us. Right now, we don't want the customers to come to us, but we want to come to the customers. So it's the long-term goal. It's clearly to launch near our customers. And for example, you have a lot of concerns because if you take a look at the National Reconnaissance Office, they don't really like to launch from a foreign country, even if they are allies. They want to launch from USA. So, and a lot of people, a lot of countries, sorry, will want this. So for national security reason, yeah, I think it's the right way to do. It's to go to have a subsidiary and a launch site in the country, if it's possible, of our customers.
What are the future plans of hydrogen?
The future plan of hydrogen. I think the space systems and satellite, the satellite subsidiaries, and maybe our bigger rocket is already great. But I think we will. Yeah, I think it's really it's enough. I think for at the moment the space systems and the bigger rocket is I think great for long term. But yeah, I think it's our vision right now. It's to help having more people, and I think I love doing business since I'm a teenager. My father is an entrepreneur, so I watched him doing his company, and I was like, okay, I want to do the same, and I learned a lot from him. But I think people we need to open the access to space, basically. And so I think it's one of Hydrogen goal and future. It's to even more help them and help people getting their satellite to space and help them doing stuff in space.
After she had answered all the questions that I could come up with, we moved on to the questions you guys asked on Twitter.
Okay, so for being a software engineer, so my goal with our hiring process right now, we want qualified people that were already worked in aerospace, but we also want unqualified people. I think we will. It's a great thing to merge the two because they will also learn. And I think, and I both Eric Berger book called Liftoff with the SpaceX theory, and Elon Musk just don't care about all your education background. They just want you to do the job and being optimistic, and it's clearly the same thing for me. But right now at Hydrogen, we have very qualified people. And to be more precise, to be software engineer at Hydrogen, it depends if you are not. Right now, we have someone that applied to Hydrogen in software engineering, and I had a job interview with him last Friday. And so the goal with him is, even if he never worked in the space industry, he already worked with ESA on a student project, but not really stayed in space at all. But he is very qualified about data, how to process data, and I think we will hire him because we will need people in data processing, in doing interfaces, so softwares, etc., computers. So I think if the biggest chance of being hired at Hydrogen is applied to software engineering. Of course, please don't apply if you are not a software engineer. But I think the job where you will have the biggest chance of being hired, because we need developer and software engineers everywhere, basically. We need it for our internal software. We need them for rocket guidance. We need them for our rocket engineering. We need them for our test stand. We need them everywhere. So it depends. I'm not against not very. I'm not against hiring people that are not qualified in terms of education level. If you just know how to code and just try to apply, and we will say if you are qualified or not. I think, so I think one of the great point about Hydrogen is we are in two markets. And it's great because if one collapses, we have the other one. I think, all startups right now are focusing on small sat. So, of course, if you take a look at the small sat market in USA, in USA, you have a lot of space companies, but in Europe, you don't have a lot of new space companies. So it's not that full in Europe. In fact, I don't only know maybe 5. In France, I think we are 5 aerospace companies, small startups that want to launch rockets. But I think Hydrogen is the only one that want to do a medium lift vehicle. And I think it's how we will be able to stand in both markets. It's because if one is full or we don't succeed in one, we have the other one. And because to succeed in the small sat market, I think you need to be ready as soon as possible. So it's a little bit hard. But I think in terms of in long term, yes, the winner will be the people that is the more cheaper with great services. So that's why we will be able to stand in this market. It's because we will have well-established startups like Planet Lab. It's a lot of other one. They do CubeSats, but they will want to build bigger satellites in the future, and so we will help them launch the bigger satellites for a small price than it right now with bigger and all the other launchers. And of course, it's to help also startups, student projects, etc., to get their CubeSats to orbit. I think we will maybe. So of course, Alhena will have upgrades because if we use electric turbopumps, electric batteries will improve with the times. You can see right now with Rocket Lab Electron, they improved performance by just the innovation in the electric batteries industry. But I think, yeah, we will maybe do upgrades. Yeah, I think I don't really know. Yeah, Alhena will have upgrades, but I think we will. It depends on the market, to be honest. If we see a strong market request, we will do a dedicated launcher. But if we see that our customers just need a little bit more payload capacity, we will upgrade Alhena. But I think, yeah, doing the next rocket is also one of our future goal is to have a fully reusable system.
All right, that is the end of the interview. I then asked her if she had any other message for all the aspirational rocket scientists out there.
I think if you want to be a rocket engineer, just believe in your dream. 4 years ago, I wanted to do a rocket company, but I was young, so I didn't know how to do it. And now I'm currently doing with wonderful people with an incredible team. And so I think, if you want to be, just do it. If you want to become something, you just have to work hard, believe in your dream, and never surrender, and just go straight. And that's what I do with Hydrogen. I started Hydrogen with just an idea, and a lot of people said it's impossible. You will never. It will never happen. And I've done a pitch in front of space leaders. People will say, but it will be. It will never succeed. And in fact, all the space leaders were very impressed by Hydrogen. It was a very good day for me. And 4 months ago, when I started Hydrogen, I was like, okay, I will hire engineers. For me, it was impossible. And now I will have soon at the end of the month 14 people working with me. So just believe in your dream. And if you want it, just do it.